Okay, so let's go on to lecture. Today we're talking about functions, more about functions. You've got the basics. We're going to talk about some additional things. We'll do announcements real fast, do the lecture. You'll do the studio from chapter 11, and then we'll come back and do the review. Announcements, Clark wanted me to be sure to tell you to complete the student feedback survey that's in Canvas. If you have not done it yet, your TAs should be giving you a few minutes in studio tonight to do it. Definitely get it in as soon as possible. While Clark is on vacation, Gracie is stepping in. They are available if you need to talk to them about your enrollment or any concerns that you have about anything, really, that you would normally take to Clark. And they'll be here for the rest of the week. Okay. So more on functions. What else can we learn, right? You've got, we'll talk about the kind of real quick refresher on the basics, just to kind of set the line for here's what you know so far, and here's how we're going to talk about things differently. I'm going to talk about the difference between calling and referencing a function. We'll talk about higher order functions, which I don't know that that term is actually in your book, but it is something that you learned about. It's just a different term for it. We'll talk about anonymous functions and a little bit on recursion. So let's refresh on the basics here. You define a function with the function keyword. You use parameters as variables to represent the input, and you use the return keyword if you're returning a value, right? So keywords, parameters, and then if you're executing a function, you call it using the parentheses. And then for each parameter, you pass in an argument in the same order. So here's an example of arguments. We have defined a function at the top, subtract nums, that takes two numbers and returns the difference. So we have these variables, total apples and apples eaten. And we decide that we want to plug these numbers into our function, and we're going to store the result, the value that comes back from that function in this new variable, apples remaining. So what would we expect that value to be?
3.
Yep, you got it. Pretty straightforward, right? So this is what you guys have learned. This is basics of functions. So now we're going to kind of talk about additional ways to work with functions. Okay, so calling a function. As we just said, you call a function with the parentheses, the name in the parentheses, to execute the code. But if you want to reference a function, you don't use the parentheses. And this is an important distinction. So let's look at this example here. We've got a function, getCopy, that takes data of some kind, and it returns data.slice at index 0. And as you may recall, the slice method works for both strings and arrays. And if you give it just one index, it's going to return everything from there to the end, right? So essentially what this thing does is just say, I'm just going to give you a copy of the entire thing because I'm going to start at 0 and go all the way to the end. So it's a great way to make a copy, especially of arrays. I don't know how much you guys know yet about the difference of the way that arrays are stored in memory, to where if you have a string and you say, I want this string to equal this other string, then you've just created a new string, no problem. If you say you have an array and you want to say this array is equal to this other array, you haven't really created a new array. You've just created a pointer to the original array. And functions work the same way. But this is why this is like the best way to get a copy of an array, or it's a way to get a copy of an array. It's a pretty straightforward one that actually would create a new array in memory at a completely different location in the memory that you can now manipulate both of them separately, and it won't change the other one. So sometimes it can be useful to have something like this. So let's say we've got this array nums 62831, and we want to make a copy of nums. Get copy, and we, so we call our function, we pass in this array nums, and it should give us a copy, right? Let's say that we actually want to now have an alias for our function. We want to call our function something else instead of get copy. I can just say let copy array and set that equal to what?
Get copy.
Yeah, just get copy. And this is where it's important. It's just a reference. You're not calling the function. So we're not storing the result of a function into copy array. We're saying, I want to start using this as the name for the function. And it's going to point to the original function. So then if we wanted to use it and we say, we're going to get another copy of nums, how would I do that?
Copy array parentheses.
Yeah, we would actually say, I want to, use this function now, copy array, and pass in the array nums, and that should give me a copy of that array. So now we have, 3 different arrays that look a lot alike, but they're actually 3 different things. Okay, so copy of nums, then if we were to console log that, we would get an array that looks just like nums. And if we console logged another copy of nums, we would get an array that looks just like nums. So here's a question for you. What would happen if I console log copy array?
It just tells you it's a function, right?
Yes, and not only does it tell me a function, it tells me what the name of the function is, which is?
Get copy.
You got it. Yeah, because somebody was paying attention. It's not just a copy of the function, it's the same function. It's just an alias. It represents the original function. So this is an important distinction. And so, yeah, so that's the basics. That's the idea. If you want to reference the name for the purposes of doing something with a function other than calling it, you just don't use the parentheses and you just use the name and that'll work. Okay, so let's talk about higher order functions. The concept of a higher order function is that you can actually pass functions into other functions. So remember that parameters are just variables, right? You assign a parameter with a name that sounds like a function name, you just don't use the parentheses. Somebody's got an open mic if you guys want to check. And then inside the function body, that's where you would actually call the function, but you would use the parameter name because that's what we do inside functions. We use the parameter names like variables, right? So that's the deal with defining the higher order function. To call the higher order function, you would reference the actual function name when passing it as an argument to the other function. And you, of course, would not use the parentheses because you're just referencing it. So let's look at this example. We've got this function join elements. We're passing some sort of an array. That's the plan. Array is the parameter there. And it's just going to join something together with space, asterisk space, and then it's also going to make it uppercase. So we have a second function, print items, which is going to take items, and we're going to set a way to pass the other function into this function. So I could say, okay, I need to come up with a name that's going to represent this function. And I'm not going to call it join elements. I'm going to call it something that's more generic. So I'm going to choose the word format, and then I can use that inside the function and say format the items that were passed in, right? And now that represents any function, but down below is where I'm going to actually choose which function. So we've got this random stuff, right? Popsicle 38 doll. And we call print items and we pass in stuff. And then we also would pass in the argument. Now, what does the argument need to be if I want to pass the first function into the second function?
Another function.
Join elements.
Yeah, it would be join elements because I've decided that that's specifically the way that I want to format my items at this point. And you could potentially have a whole bunch of other functions that format things differently, and whichever one you pass in is the one that's going to basically filter your items through and format them that way. So I would expect that it comes out as a single string that's popsicle space asterisk space 38 space asterisk space doll. Because print items actually took that specific function and used it to format the items. Does that make sense?
I have a question.
Sure.
What the line of format of items this format? That's a function, right?
Yes, that's the variable name that's representing the function.
And
Yeah,
then I actually thought like a format is a different function which has not been written in that screen. I thought in that way.
right. No, so so the idea here is that we just come up with a parameter name format, and that represents any function that we could pass in. And whichever one we pass in, we're going to call that function. And because we've given it an alias format, we can just call it like this, format, and pass in the items. So down below where we actually call print items, that's where we pass in join elements as the specific function that we want to be represented, and its alias is format.
Okay, I got it. Thank you.
Yeah, so this is the concept, and we're going to look at some more examples here in a second. Yeah, there's lots of ways that that this can work, and so we're gonna look at one that actually picks up where we left off with the end of studio review last week, where we were talking about all of these functions, adding and subtracting and all this stuff, and like, how you'd have to come up with all these different functions to make it work. So we had this concept of the black box. And so, the question is, what if a function could be flexible enough to work for a variety of uses? What if we had a single function that could add, subtract, multiply, and divide if we give it two numbers? So if we did that, we would expect these to come out as, 5. And then if we're subtracting, it would come out as 2. If we were multiplying, it would come out as 30. And if we were dividing, it would come out as 3, right? So you might be like, how can one function do all of this? Well, it's because we are going to provide the function with a specific function just to do the math. Okay, so this is where I am going to switch over to Repl. And we are going to take a look. I've got these other examples in here from before, but we're going to jump down to here. Okay, so if we are passing functions into a function, this is kind of, if you have these 4 functions that were your utility functions, all they do is just take care of the math, right? Add, subtract, multiply, and divide. You can see that they each return something different, and they take care of each of the operations, right? And again, similar to what we were doing with the studio review last week, you have this, print equation, and what if you have, your equation is, and, you make this function, I'm sorry, you make this sentence that basically just takes whatever equation, so you would assume that's a string, is passed in, and it's just going to print it. That's all that it does. So it's another utility function. So, we had come up with this custom function, and I keep saying studio review, and now I'm thinking it was lecture, but it's okay. We had this, add and print, right? And we would call, let sum equal add nums, and then print this, n1 plus n2 equals sum. And this is the string that we are feeding here to print equation to get this thing. And so this is what we actually see in the console. So if we wanted to do this the way that we have known how up until now, where all we do is pass things like numbers and strings and Booleans and whatnot and arrays, we have to have 4 different functions to do this, right? Because we have to call these differently. But what if, and I'll run this so that you guys can see. Yeah, So we get these results because each time we print it, we come up with something unique because we've called a different one with each one. What if we could do this with just a single function? So that's what we're going to try to do here. So what if we write a single function that can handle all 4 operators? First of all, we know that, to set our parameters, we know that we would need, N1 and N2, right? And we would need something to represent these 4 functions up here, add nums, subtract nums. So maybe we just call it, calc. And then we come in here and we say, okay, so before I was saying, let sum, let diff, let product, let quotient. Let's just say let result to be generic. And we'll say equals. Now, if I want to call one of these functions, how am I going to do that now?
Calc with N1 and N2 as parameter.
Exactly. You got it. So because this, now I can pass in any of those 4 functions, I can just use this variable from this parameter to stand in for any of them that are passed in. And no matter which one I actually pass in, this will go and run it and return that value and store it in result. So then we go to the next part. We're going to print equation. And we've got this, template literal here, N1. And we've just run into a problem, haven't we? Because we have, plus, minus, we're going to have an issue. Let me finish it and then we'll talk about that. And then, of course, this would be the result. So now we have a problem because one of the other things that was hard coded into these 4 functions was this operator. So what would be one way to handle this?
Calc. In parentheses.
The parameter, a generic parameter.
Yes, we could have another parameter and just call it like operator, and we could pass that in as a string so that we can specify it. This is one way to do it. I'm going to show you another way to do it in a minute. So, all right, so we've got number 1 operator, number 2, and then equals result. And that's going to be our whole string that we're passing into print equation, and then print equation should do the same as it did before and say your equation is, and then print that string that we just passed in. So let's do it this way. And we've got, plus, minus, times, and divides added in there as a 4th parameter. And we get the same result. That's good, right? Okay, so that's one way to do it. Another way would be, what if we wanted to eliminate that 3rd parameter so that all we have is just the 2 numbers and the function that we're passing in?
Before we move on, can I
Yes.
ask one question?
Mhm.
When you added an operator as a parameter, how did that work to make it to where it was either plus, minus, division, or multiplication?
We pass it in hard coded like this.
Okay.
Yeah, so I'm choosing add, and therefore I want it to be a plus sign. I'm choosing subtract, therefore, yeah.
I
So
see now.
right, so that's kind of the manual way of doing it because you have to
Right.
hard code it, which is why now I'm going to show you a different way to do it where we could automate it.
Okay, thank you.
Yeah, absolutely. So here's this function I've written called get operator. And I have passed in that same function, calc. And I mean, I've used the same exact parameter name, but the idea is that you would be passing in whichever function came in. And I'm just checking and saying, which one of these is it? Is it add nums? Is it subtract nums? Is it multiply? And then of course, else would assume it's divide, because we would only ever be using it with one of these 4. And then it'll return, it does these early returns with, if it's this one, return this. If it's this one, return that. So in theory, now we no longer have to have it as a parameter here because we can just call this function along with the math function that we've passed in and let it figure it out for us. So let's see what that looks like. Again, we've got N1, N2, and then, calc. And maybe just for the sake of clarity here, I'm going to call this calc nums this time. Not to be confused with the calc I just used over there. Or maybe I should have done it the other way around. Yeah, let's do it the other way around so that this is similar to, hold please. Okay, just so you're clear on which parameters belong to which function, because I know this can get real convoluted real fast for you guys. Okay, so now we can kind of do the same thing. And I'm just going to copy this over because it's almost exactly the same. Except here, we're no longer passing in an operator. So what are we going to do instead?
The get operator function,
And what do I pass into it?
the add nums or
Calc.
calc. Oh,
Calc, yeah, because in this function, calc stands in for any of those, add nums, subtract nums. This is what it's allowing us to be flexible, so we can use any of them right here to get the result. So yeah, we just pass that in, and this one takes it, and then it checks and says, okay, which one is it? And then it returns, this represents the return value of either the plus, minus, times, or divide sign. And so now if we run this, and comment those, we should get the same result, and we do. Okay, so before I move on to anonymous functions, any more questions about that?
I have a quick question.
Sure.
I was just wondering what would happen if you use strict equality instead of loose equality with the in return or if else statements.
That is an excellent question, and I'm glad you noticed. It should be the same because they are they point to the same thing in memory.
Okay.
Yep.
I'm Scary. Can you please go up with a bit?
Uh-huh.
Yeah, I want to see the function. Okay. So
What-
I have a question here.
Uh-huh.
So why we are like using two different calculate and print and alternative?
Because this one is where I was showing what it looks like to hard code these symbols, to have to pass them in as a fourth parameter. And then this here is where I said, I'm going to write a function to handle that and return those values. And then we don't have to have a fourth parameter here because we can just call that function with passing in the calc function, and that this will tell us which one we need. So it's just-
Function get operator and for calculate and print alt is enough for to print the values.
So yeah, get operator takes whichever function you passed in, whether it's add nums or subtract nums, it'll come up here into get operator, and it compares them and says, which one is it? And whichever one it is, it gives you the correct symbol. And then that symbol will be here between number 1 and number 2, like you see over here in the readout.
Thank you.
Yeah. So so basically I'm just showing you two different ways to do it. And these are the kinds of decisions. It's usually good to automate things to avoid mistakes. And so something simple like this can save you a lot of headache on having to hard code and have that fourth parameter, put it in every time, because you'll get consistent results this way. So, okay. Let's go back, if I can get, there we go. Go back to the slides. Let's talk about anonymous functions. And we are going to get some more practice here in a second with this concept. Okay, so anonymous functions allow you to define and use a function in place. And what I mean by that is you don't have to define it with a name ahead of time. So it's kind of, anonymous functions are the opposite of a named function. So if you don't need it more than once, you don't have to name it. You can actually just create it. And this is very commonly done with higher order array methods, such as map, for each, filter. There's other ones too, reduce. There's a whole bunch of them. And I know in your textbook, they gave you some examples of how to do map. We're going to do one of those here. And then I'm also going to give you an example of for each and filter. You guys are not expected to be able to use these casually like professionals do at this stage. but it's a great way for you to see how this higher order function thing works and get a little more familiar with the mechanism of it. Okay. So the syntax is almost the same as writing a named function. You just don't use a name. It really is that simple. So we've got an example, let letters equal B, C, D, and T. And then I'm creating, that's an array. I want to create a new array using map. And map, if you remember from your reading, it takes one array and it returns another array of equal length. And it just allows you to manipulate, to do something with each one of the elements. And it loops through them and looks at them one at a time. And then you do something, and then it creates a new array with those new values that represent, that correspond, I guess, correlate to each of the elements in the original array. So words is our new array. And what I'm doing is I'm gonna add some more letters onto each of those letters to create full words. So I take letters, I attach the map method because it's an array method, and then I'm going to give it an argument. So, you see we've got these parentheses here, typical, I'm passing something into map. Well, map takes a function. And this is a great way to practice using anonymous functions. I don't need to create a function outside of this. I'm doing something very specific. I'm only going to do it once. So why not just put it right here? So I'm going to put the entire function, boom, right inside those parentheses like that. And this way, the way that this is formatted is kind of standard, to have the closing parentheses be right there with, the closing curly brace be right there with the parentheses at the end. But you can see I've just said function, and then I've not given it a name, but I still have a parameter, and I'm calling my parameter letter, and that just stands in, because it's looping through, it just stands in for the element. I could have called it element. I could have called it anything I want. In this case, I'm being specific because I know it's a letter. So it's going to go through, it's going to run this function for every single one of the elements. And for each letter, it's going to return letter plus OUGH. And that would be, then it'll put that into a new array for us for each one. So if I go and I console log words, what am I going to see?
Golf. Go, golf, go, stuff.
Yes, I love the English language. Bow or bow, cough, dough, and tough. Yep. All completely not at all rhyming, but they have the same 4 letters on the end.
I have a quick question.
Yes.
Should that be letters or just letter?
Letter, because it represents a single element.
Okay.
That's the key. That's the key with these array methods, is you have to remember they loop through and they look at one element at a time. So your function is intended to just operate on that one element while it's there. And then it's going to do it up for the next one. And then it's going to do it for the next one. I'm going to show you in a minute. In fact, I can do it now. Exactly what's going on behind the scenes there. And then we're going to look at a couple examples for each and filter too. So let me do this. I'm going to switch over. We'll come down here. Okay, so here's our example with the letters, right? And I've got this set up to map through the letters array, look at each letter at a time, and return letter plus OUGH and put that into a new array, words. So let me comment this out so we can focus on the one at hand. So we have this coming out as expected, bow, cough, dough, tough. And we can see better exactly what's happening if we throw a little console log in here, right? So let's just console log, the current letter is, and then we'll just say letter. And this will help you see what's happening as it loops through. Okay, so you see that the current letter is B, the current letter is C, the current letter is D, the current letter is T. So it went through, it looked at them each at a time, and then it added these words into this new array. Mike?
Like I understand what you're saying there. How does it okay, so I understand letters has the elements B, C, D, T. how does letter work if we've never given it a value? Does that make sense, what I'm asking? Like, I feel like if I did something like that and just dropped a letter off my array, it would be like, syntax error. Does that make any sense? I don't understand how it knows what to look for with letter, because that's an input you're giving it, right? The parameter?
Yeah, with the way that map works, so that this is where it's tricky. You're not writing the map function. You're just playing by the rules of the map function, the map method that belongs to arrays. And the map method, its rules are actually, I can highlight it and it'll tell us. Yeah, here we go. So it tells you that it can, it's going to map through, it's going to go through one at a time. And so when you give it a parameter, you're basically saying, make this represent the element that you're on.
So by doing that, you've essentially declared letter to be
Whichever element it is.
value wherever it's at. Okay, I'm with you. Okay, thank you.
Yeah, and that's a good question, Noah, because it's a good distinction to make that I'm not making, I decided to call it letter. I could have called it anything. But that's just playing by the rules of map because this is a pre-existing higher order function. And the thing that we're customizing is what function are we passing into the higher order function map.
So I'm focusing on the fact you called it letter versus letters, but you could have called that like Play-Doh
Yeah.
and it would have done the same
I
thing.
could have
Wouldn't have
called, sometimes you'll see when people are being real generic like this, they'll call it L, standing for element. So I could have just done, L and it'll still work. Yeah. That makes sense? So we can do the same thing and kind of look at how to do this for each. For each is another array higher order method. It is kind of like map because it goes through each one, but it doesn't create a new array. It just does something with all of them. So essentially what this is a fancy loop. That's all it is. And so I've got this example here where I've got names.forEach and I'm saying, okay, I want to go do something. In this case, I want to print something. So I'm going to look at these one at a time. And I'm giving it name because it's one name at a time. And for each one, I'm going to give it title case. I'm going to take the very first letter of name and make it to uppercase. And then I'm going to concatenate on the rest of the name as it is. If I wanted to be real particular, I could say 2 lowercase, but they're already lowercase, so it's okay. And let's just say I know that going in. That's fine. So I can run this, and I need to get that other. Okay. And now I see L, Nancy, and Max. It prints them one at a time as it's looping through. So like I said, it's very similar to map, except that it does not return a new array. It just allows you to look at it just allows you to loop through and do something. Okay. And then filter is pretty cool. Use this a lot, actually, where you can have an array and you can go through and say, I want to find some criteria and I want to filter this down into an array of just the things that meet that criteria. And so in this case, I want all of the numbers that are less than 10 to end up in this array. And this is another one like map where it actually creates a new array. It's just that with filtering, you would expect that if it finds, some that are true and some that are false, the array is not going to be the same length necessarily, right? It might be smaller. So we want to store that new array in a value. So we say less than 10. And then we say, okay, I want to look at integers. I want to call the filter array method. And I'm going to pass this function into it that is going to return either true or false. And so the function is that for the number n, only include it in the new in the new array if n is less than 10. And this return keyword is important when you are doing it this way with the syntax, to make sure that it actually is giving you that value back. Is it true or is it false? So is n less than 10? So if we cycled through this, it would be false. And then when it gets to the 8, it would be true. And then when it gets to 22, it would be false. So it goes through and looks at these one at a time. And then the result is the array less than 10 should only have integers in it that actually are less than 10. So let's run it. And sure enough, it does. It just has the 8, 3, 7, and 4. Because that's the only, those are the only ones for which this returned true. Okay, don't fuss too much about
I
remembering.
have a
it.
question here. You can, why you need that filter keyword there? Because already the function there, it will return whichever the numbers is less than 10, right?
Because filter is the function that actually takes care of the behind the scenes part of that. You would have to have your own series of loops and if else conditionals, and or I guess you just have to have an if block. We could do this the way that we know how. And I don't want, just so you guys, before I answer any more questions, I don't want you to get hung up on filter and for each. You're not expected to use these. What I'm trying to demonstrate is that these are common ways that anonymous functions are extremely useful, because you can write the entire function in place and say, this is what I want you to do when filter runs. Filter belongs to JavaScript. It's an array method that's built in. And it loops through and evaluates each of them one at a time. And this is the basis on which it evaluates it, whatever function you give it, as long as it returns true or false. Okay,
Okay.
yeah, Rainey?
Okay, I have a really quick question, I promise, I think. You can use method chaining for this. So like, I guess that's my question. Can you use method chaining for this? And like, is that something that people do for anonymous functions?
Yes. Yes. Like, let's say I wanted to, yeah, you absolutely could. Like, I could say I want to go through and I want to filter all the integers that are less than 10. And then I want to use for each or map, and I want to go through and I want to do something else to them, or I want to, use for each. And yeah, I mean, there's lots of ways you could do a lot of different things with it. But I don't want you to get too hung up on it, like I said, because this is more advanced stuff. I just wanted to focus on the anonymous function aspect, just to show you that when you need situations like this, it's extremely useful to be able to just pass an entire function into one of these things. Yeah. Okay. Let's move on, because we still need to talk about recursion. Okay. Recursion, again, this is a more advanced topic. Launch Code chooses to introduce you to it because it is something that is good to know about. We don't expect you to use it heavily. You don't really have to master it, but we do want you to understand the basic concepts of it so you have a general idea of how it works. So I'm going to look at one function here, and then when we when we do studio review tonight, the bonus part of the studio review is a recursive version of one of the functions you'll have written. So we'll look at that too. So recursion is the idea of having a function that loops on itself, essentially. So you can keep looping through data by calling the function again from inside itself. But you have to have a way to stop the loop. We call that the base case. And it can be written as an early return. This will make sense to you in a minute. But it's often a very efficient way of solving a problem when you're working with a large set of data. Because I think the example they give you in the book, they've got some examples, and your studio tonight is another good one of like sorting numbers. Like if you have to go through the entire list over and over and over again with a really big data set, that can be, really costly time-wise and memory-wise. So let's look at this example. Nothing on here is recursive yet. I'm just showing you the normal way to do it, that you know how to do it. This is a little bit like your exercises from last week where you're creating these shapes, right? What I've done here is say, I'm going to create these steps. I'm going to use a basic for loop. I'm going to go from 1 I equals 1 to whatever the n value is that's passed into the function. And for each one, I'm going to repeat this O, this 0, I times, and then I'm going to repeat n minus I the remainder for that the dash, the hyphen. And then of course, because this is a for loop, it's automatically incrementing each time by 1. So on each one, it changes what the difference is between the two, right? So if I call this function create steps and I give it the number 8, you can see it starts out with 1 and 7, and then it's 2 and 6, and then 3 and 5, and so on and so forth until it gets to the very end, and all 8 of them are the first character. So this is a pretty straightforward example, and I want to show you how we can do this recursively. All right, so let's look down here. Here's the original function, and just to demonstrate it, we'll run it. And let me take that out. There we go. Okay, so we have, these steps that you can pretty clearly see, are different on each row. So if we wanted to do this recursively, we definitely need to be able to tell it how many, right? So we have to have at least one parameter. And according to our rules, we said that you have to have a base case, right? Some way to stop the loop. That's really important because otherwise you'll just have an infinite loop. So we have to establish what that is. What's the condition on which, well, okay, so I guess I'm going to need to give you, we also have to have, so n is the number, but you'll notice that, we worked with this iterator I, right, to give us something to do the math with, like I and n minus I. When we were doing this, we need to do something similar. So we can have the second one be I. And so then what would the base case for this be?
If n is less than
Condition.
not,
Think about it. If I is greater than n, that's what we want, right? Because I is going to keep building. That's the idea. Just like it does up here. We want I to increase every time. And so if we ever get to the point where I is greater than n, then we just want to return. We don't want to have it print out any more steps. And then we just do what we normally would do and say, we want to print this, right? We want to print this character 0 repeated I number of times plus the character hyphen repeated n minus I. That part doesn't change. We want the same results that we see over here. The part that is, this is where it becomes recursive, is we're going to call our function on itself. But here's the key. What do we put in as parameters here? I'm sorry, as arguments for our parameters.
I plus 1.
n minus 1.
I think we would use n and then we would increment I. So we do I plus 1.
Good. Yes. Because I is the one we want to change every time. And we can see that by looking back up at the way this is done. And I called it I on purpose. I mean, just because I wanted you to see the similarities with how it's done, because you're basically just replacing a for loop. And in this case, we're starting with 1, we're increasing, incrementing every time by 1, up until we get to n, but no higher. So so this is why we need to have this second parameter. And we have to feed it in with an argument when we call it here, because we have to be able to increment it. Otherwise, we just end up in an infinite loop. And so then we can actually call it, but because we gave this, this value of 1, we could actually just, give it the 8. And so let's run that and see what happens. Good, and it works. But here's the thing. This is a default value, right? But it doesn't have to be 1. What if we gave it 3? Oh, let me get rid of this other one so it's less confusing. Yeah, so we could actually say, I want to start with 3 steps and go up to 8, right? So by giving it that second parameter, it not only allows us to increment it, but also, you know, we can actually pass something else in if we want to, other than 1. Okay, who has questions? Because I know this can be confusing.
Yeah, in case when we're passing 3, so the I will be like equated to 3 instead of 1.
Yeah, so it means I starts at 3, and then when you call it again, it takes it up to 4, and then when it comes back around, it takes it up to 5, and so forth. And then when it gets to 8, well, when it gets to 9, it comes here and says 9 is greater than 8, because n never changes, n is always 8. And so then it just returns without printing anything else. Yeah.
In line 161, is that essentially the same thing as like reassigning a new value to a variable? Because you're calling the function within itself.
No, you are actually calling the function. So it's starting at the top and evaluating it completely afresh. Let me see if I can find your, I know in here, they had a diagram that I think is really helpful. Let me find that.
So that was a way to make it loop itself.
It's looping itself. Yeah, exactly. So visual representation. I feel like they had a different one. Hold on. Nope, maybe not. Base case. Maybe not. Okay. Yeah, they sort of have this. It's like you call this in this example, call combine entries, give it, you know, the array with both. You return the first one and then call the thing again with what's left. And then it returns just that one. And so then it concatenates them together. And now you have the combined entries. And here's one with a longer array, LC101. So you can see it returns L, and then you call the thing and you give it the remaining values, and then it does it again, L plus C plus combined entries with 1, L plus C plus 1, L plus C 1, LC1. It is actually calling it. It's just you're passing in something new, and then it's evaluating it as if that's, you know, all that's there. I'm going to find, there's another diagram I was thinking of that I guess is not in here. I will see if I can find that, and I'll add it in as another slide, and it'll be there when you guys come back to the slides, but I'm not going to take the time to look for it right now, because I know that this can be hard to wrap your mind around. But yeah, you call the function from inside itself, and then it basically just starts at the top with whatever you give it. And this has nothing to do with anything that happened from here to here. But yeah, this example just prints things. And so because it just prints things, it's harder to see the part about how it's returning values. And that's really, I think, where another example of how it's returning values. So when we do the studio tonight and we're doing the sorting thing, I think that'll become a little bit clearer, because we're going to be using something where it actually is returning something and not just printing something. Okay.
I have a question. It might be a silly question. Is repeat a method in JavaScript for repeating the character or the digits?
Yep.
Okay. Okay.
Yeah, that's a string method. I don't think it's one that we have talked about before, but yeah, instead of having to loop through and like concatenate a bunch of zeros, you can just tell it how many you want. It's a shorthand way of getting a whole bunch of the same characters in a row. Yeah. Okay. So, you know, I can run this again. Yeah, so this goes from 1 to 12. This one goes from 3 to 8. Okay. With that, you know, if you're scratching your head on recursion, like I said, don't fret, because it's not going to be on the test. You're not expected to do this in anything official. And if you do, that's great, because it can be very useful. But it's okay if you don't. But I did want to just make sure that you had a little bit of exposure to it. It's the same reason that the lunch code puts it in the chapter. They just want you to have some exposure to it. Okay, so let's talk about Studio, because we're coming right up on 6:30 here. Tonight's Studio is chapter 11. You're going to write functions. First, you'll have a helper function, a utility function that just finds a minimum value. And then you'll write a function to sort numbers that's going to make use of the first function in order to handle the entire array and sort it. And then you're going to look at some other sorting, the other ways that sorting can be done in JavaScript. It's going to kind of walk you through that. And then if you have time to do the bonus, you can try to come up with a recursive solution for sorting. And I will tell you right now that if you ever interview somewhere like Google, there are a bunch of like, you know, tried and true recursive solutions with, you know, using different approaches for sorting that you'll want to know inside and out, but you don't need to know that now, because you guys are new at this. Absolutely not. So we can look at this. I will show you I got to go back to where I was before. Here we go, Studio. Okay. Yeah. So we talked before about how you can't just sort numbers with dot sort and just give it the array, because it sorts them alphabetically. So this is where you're going to investigate kind of how to do it properly so that it's numerically sorted, which is what you're going for with numbers. So part A, again, find the minimum value. That's all that function should do. And then part B is where you'll write something that uses the find minimum value function. And talks a little bit here about, like, you know, do you want a for loop? Do you want a while loop? You're going to want to investigate that and kind of figure out what you think works best. And then, yeah, this is called a selection sort, the first one. And so it's going to also introduce you to how to use sort as a higher order function and pass in a function that gives it rules for how to sort things. And, you know, how does that work differently than what you did with the stuff you created up here? So this is all really good stuff. This is extremely practical. This kind of stuff is used for a lot of things. So it's a really, really good exercise. As always, work together so that you can help figure this out together and pair program. And we will come back here at 8 o'clock for a studio review, and we'll walk through all of this.